Hello everyone, welcome to DevNexus. Today I am going to discuss the problem merge sorted array. So here we are given two integer arrays nums1 and nums2 sorted in non-decreasing order and two integers m and n representing the number of elements in nums1 and nums2 respectively. And we need to merge nums1 and nums2 into a single array sorted in non-decreasing order. So and the final array, sorted array should not be returned by the function but instead be stored inside the array nums1. To accommodate this, nums1 has a length of m plus n where the first elements denote the elements that should be merged and the last n elements are set to 0 and should be ignored. Nums2 has a length of n. So basically here we are given two arrays nums1 and nums2. We need to uh, sort we need to merge these two arrays and so in such a way that our output will be sorted. So and we need to return nums1 array. Basically we need to merge these two arrays in nums1 in sorted order because we are already given nums1 length should be equal to m plus n and the remaining elements where are equal to 0. So I mean last n elements you can say is equal to 0. So we have to merge in such a way that our final output array should be sorted. So let me explain you how what's this saying. Basically here we are given two arrays 1 2 3 uh, 0 0 0. This the length of this particular and one more array we are given 2 5 6. We are given n is the length of the second subarray which is 3 here, and also we are given m is something which is the elements of the first array which are not equal to 0, so number of elements which are not equal to 0. So here m is 3 only and the length of our array is 3 plus 3 6 which is m plus n. So now we are given these three elements are uh, defined as 0, so they just not exist. We just need to merge them in such a way that our first array should be of length 6 and it should be sorted and everything should be in nums1 only. So our output should be 1 2 3 and I think 2 should be here 2 5 6. This is our output array and this is in nums1. We need to modify this array and make it to this particular array. So this is the problem. So let's try to find out how to solve this problem. So let me take one another whiteboard and I will explain. So here we are 1 2 3 0 0 0 and 2 5 6. The best way to solve this problem is by taking a temporary array which will definitely help us of the length 6 of length m plus n. This is m, this is n, this whole is m plus n. So here what we can do very simply is that these two arrays are sorted. So this is our temporary array of length 6 which is m plus n. So what we are going to do, we are going to start from these two pointers and check which one is smaller. So we find that one is smaller, so we will append 1 here and increment this point, this part. Now we will check 2 and 2 both are equal, so we can traverse either of it. So let me traverse this only. So I will add 2 here and traverse it 3 here. So now we will check 3 and 2. 2 is smaller, so we will add 2 here and traverse 5 to this position. So now we will check 3 and 5. 3 is smaller, so we will add 3 here and increment our pointer to this position. But now we can say that our length of m has been exceeded. So now we will just add all the remaining elements of length n. So we can do the same for, so likewise with temporary array we can solve it, and now we can modify our update nums array with these values, and we can return nums array. But this will take on as our time complexity, but also space complexity is also on. So there is much better approach uh, to solve this problem with space complexity O1, where we shouldn't be needed temporary array. That is the best optimal solution that I will explain, and we will use that only. So let me delete it again and let me open it. It is 1 2 3 0 0 and 0, and it is 2 5 6. The better way to solve this problem is similar to it only, but what we can do is, like, we can start adding the elements in the array from the rear end, from the last side. That will be much better, because if we can see this pointer and this pointer, we can do our things from the last array. So what we can do, we should compare 3 and 6, which is greater. So here we will check which is greater. So 6 is greater, so we can directly put 6 here and make our array to 6 here, last element, and decrement our this pointer. So our pointer will reach to this position, this pointer, and then we will check 3 and 5, which is greater. 5 is greater, so we will put directly 5 it here, and then we can decrement 2 here, decrement to 2 to a position. Now we will check which is greater, 2 or 3. 2 is smaller, so we will add here 3 and decrement our this pointer. Let us say this one is a pointer and this is b pointer. So b has reached to this position and a has reached to this position. Now we will check which is greater, 2 or 2. Here we can say that it is same only, so we can, for now we can just take this only, and we will decrement 2 here and place 2 it here. And now we can say directly see that our elements are sorted. Like, we can say that I mean the second element has completed the array. So now all our left elements will be same only. So our output will be 1 2 2 3 5 6. So this is much better approach. With this we don't need any extra space. So let me explain this solution with the code, which will be much better to understand. So first of all, I'm going to take my r1 pointer, this one pointer, a is my r1 and this is my r2 pointer. R1 is m minus 1 and r2 is n minus 1, and our k pointer from where we are going to modify our array, which is 0, this position, which is k. Now what I am going to do, I am going to traverse my array from the last position by saying, once my r1 is greater than equal to, sorry, my r1 is greater than equal to 0 and my r2 is greater than equal to 0. In either of the cases I have to check it, because there is one possibility also that these all elements are very big, 9 8 7, all are greater, so all will go here, and our r1 pointer will become minus 1. So that case also we have to consider, and same for r2 also. There is possibility that it will go to minus 1, for which case, for this particular case we have seen it, when we decrement this pointer, our r2 pointer becomes minus 1. So that's the reason I have added these two conditions. So now what we are going to check, if our nums1 r1 is greater than nums of 2 r2, then in that case we are going to modify our kth value with nums1 r1 and decrement our r1 pointer. Same for opposite for this thing, nums2 of k, sorry, nums of 1 of k. If our r2 value is greater than equal to r1, then I'm going to append this 6 to kth value, just nums2 and r2 pointer, and then we will decrement our r2 pointer, and in either of the cases we have to decrement our k pointer, which we are doing it by, this is our k value. Every time which whenever we append anything to this position, we decrement k pointer every time. So likewise we will be doing this. One thing which we need to keep in mind for this particular case, what we have seen it, that when r2 becomes -1, then there is no need to modify our array, because all the values will be remaining same only, whichever is there in our um, a array. But there is scenario, what if our a r1 pointer becomes 0 -1? So in that case we have to check this condition. When, so for that case only I will use this thing only, where I am going to add nums1 part k is equal to nums of 2 r2 and r2 minus equal to 1, k minus equal to 1. So this thing we have to do it separately. We shouldn't be doing r for a separate thing for r1 pointer, because it's already in r1 only, so that we don't need. But for r2 we really need it, so that's why, so that we can modify our array properly. So let's see how it works and check if there any issue or like. Think there is some issue. It worked fine. So yeah, it worked fine. It was a good problem. It was a two pointer problem, r1 and r2. So this is it. You can see the problem again and try to find the issues. If you have any, you can comment it. I can answer those things. And it was a good question. So for more updates, please subscribe to this channel. Yeah, thank you.